Hello. Hello guys. This is Devdut Mitra from Chemistry AZ Academy. Today we are going to see the relation between four quantum numbers n, l, ml, ms. N represents the principal quantum number, l represents the azimuthal quantum number, and ml represents the magnetic quantum number, and ms represents the spin quantum number. Okay, the relation between principal and azimuthal quantum number can be shown by the following relation. L is equal to 0, 1, 2, 3 up to n minus 1. So you understand, L is the azimuthal quantum number where n represents the principal quantum number, and the relation between azimuthal quantum number and magnetic quantum number can be followed by these two relations. 12 plus 1 represents the number of orbitals and ml represents the number of L's. That means how many number of rooms present in an orbital. You got it? The last relation, ml is equal to plus minus l, comma plus minus l minus 1, comma plus minus l minus 2 up to l till up to l is equal to 0. This relation represents how many rooms, how many suborbitals may present in an orbital. Okay, we will see the result. So there are two more columns here. Maximum number of electrons may present in an orbital and total number of electrons in an orbit. So when n is equal to 1, that is for K shell, you get the value of azimuthal quantum number L putting n is equal to 1. So 1 minus 1, you get the first value 0. Relation between n and l for the first orbit, then we get 1s. 1 represents the principal quantum number and l represents the s orbital. When see the result, when l is equal to 0, it represents s orbital. When l is equal to 1, it represents the p orbital. Like this, l is equal to 2, then it is d orbital, and l is equal to 3, f orbital. There are four orbitals. S orbital means sharp or spherical, p orbital means principal of elliptical shape, and d orbital, it represents the diffused, d for diffuse orbital, and f for fundamental, very complicated shape. So when l is equal to 0, you understand why l becomes 0. We get the value n, putting n is equal to 1, 1 minus 1, we get value 0, right? And the address of the subshell, here I have written here, address of the subshell, that is nl. So for first orbit, value of n, that is principal quantum number, is 1. So 0 represents 1s orbital, 1 represents the n value, and s will come from l. When l is equal to 0, then it represents s orbital. So s represents the value of l. We can represent 1s orbital with the help of box diagram, and the value of magnetic quantum number may get from this relation. You put value l as 0 in 12 plus 1, ml is equal to 12 plus 1. You see the first one. So what we will get? 2 into 0 plus 1, that is 1, and ms represents the spin quantum number. This is spin quantum number. So in one room or one orbital, that is 1s orbital, total number, maximum number of electron may present 2. Each electron has plus half and minus half. Sir, what do you mean by plus half and minus half? You understand that electron has negative charge. So how could it be possible for two electrons present in one room? Because there may be a chance of negative repulsion, but it cannot. Actually it cannot. Why? Because both electrons, this one and this one, have opposite spin. that is plus half represents the clockwise spin, minus half represents the anti-clockwise spin. So neither of two electrons can interrupt with each other because they have opposite spin. Both carry negative charge, but due to opposite spin there is no repulsion. So they present in one orbital. With the help of ML and L relation, we get the value of L, that is 1. 1 represents one orbital, one room in 1s orbital, and in which ms represents a spin quantum number, that is plus half and minus half. Both electrons may present in the same room, but they do not repel with each other. Why? That I have told. Plus half and minus half, that is plus half means one electron having clockwise spin share half portion of the room, and minus half represents another electron with opposite spin, that is anti-clockwise, share the other half of the same room, right? So maximum number of electrons in an orbital is 2. Okay guys, total number of electrons in an orbit, there is no other part, so it should be 2. Okay, this is for first orbital. That means in first shell, that is K shell, maximum number of electrons may present in an orbit is 2. Then we will go for second shell, that is L shell, when value of n, that is principal quantum number, is 2. For the similar way, in the similar way we get the value of L putting the value of n, that is 2 minus 1. So next L value will be 1, and see, when L is equal to 1, it represents p orbital. Okay guys, I hope that you understand. Okay, I am telling it again. 0 1, the first it starts with 0, L starts with 0, and next value will be according to value of n. So n is equal to 2, so you put the value of 2, in the place of 2 minus 1, so you get value of L is 1, right? And it represents 2p. Why it is 2? Because the value of n is 2, and p, when L is equal to 1, then it is p orbital. Okay guys, in the similar way we can get the value of ml, that is magnetic quantum number. Here I am writing here. So 2L plus 1, 2 into 1, why? The value of L is 1, 2 into 1 plus 1, so you get total 3 orbitals, right? You understand, na? There are 3 rooms in the 2p orbital. There are 3 rooms, that means 3 suborbitals in the 2p orbital. So with the help of the last equation, plus minus L, with the help of this relation, we can get the values of 3 rooms, minus 1, 0, plus 1. That is minus 1 to plus 1 is the range, which may represents x-axis along the expansion of orbital, may be x-axis, y-axis, z-axis, right? So each room maximum number of electron may present 2, each of plus half and minus half spin. So there will be, with the help of spin quantum number, we can get the total value or maximum value of electrons may present in the 2p orbital is 6. So in the second shell, total number of electrons, or you can say maximum number of electrons may present in the second shell, 2 plus 6, that is 8. You see, it is orbital, it is orbit. So the value 8 comes from in accordance with 2n square rule. If you put n is equal to 2 and write 2 into 2 square, what will you get? 8. So see, you get the value, same value according to 2n square rule, that is 8. You understand guys? I hope you can. Next we will go for n is equal to 3, that is third shell or M shell. you get the value of L in the similar way. Put here 0, 1, and in accordance n is equal to 3, you put 3 minus 1, what will you get? 2. Okay guys, this is 2. So when L is equal to 2, when the value of L is equal to 2, it represents d orbital, so it is 3d. Sir, why it is 3d? Because you get the value of n as 3 and address of the subshell is nl, so you put 3 in place of n, and L, as L value is 2 and 2 represents d suborbital, so 2 is equal to 3d. 2 L value 2 represents 3d orbital, right? You get the point, is not? So this is 3s, representation of 3s, that contains 2, maximum number of electrons is 2. And like the same way we get the maximum number of electron present in 3p orbital, plus up minus up into 3. Sir, why it is plus up minus up into 3? Because it represents in 3 rooms maximum 6 number of electrons, each of plus half and minus half, it distributed in 3p orbital like this. In each room maximum number of electrons is 2. Okay, and what will be the value of ml when L value is 2? You have the relation. Now put L is equal to 2, so what will you get? 2 into 2, that is 4. 4 plus 1, what will you get? 5. So maximum number of rooms present in 3d orbital will be 5. How, sir? You put the value of plus a, you can get the value of the range from minus L to plus L. You put the value of L as minus 2, so you get the first one minus 2, minus 1, 0, plus 1, plus 2. Okay, you got the point. And minus 2, minus 1, 0, plus 1, plus 2, what actually it represent? It represents the direction of each room. It may be xy, it may be yz, it may be zx, like this. Okay, so you got the point. ml is equal to 2 into 2 plus 1, that maximum number of magnetic quantum number is 5, which represents the 5 number of rooms or suborbitals may present in 3d orbital. So maximum number of electron having plus up minus up shared in the 5 rooms will be 10. I hope that you understand it. So the maximum number of electron may present in third orbit, 2 plus 6 plus 10, what will you get? 18, which is again in accordance with 2n square rule. And for the fourth orbit, that is n shell, when n is equal to 4, we get the value of 4s, 4p, 4d along with their maximum number of electrons up to 18, right? But in the case of 3, when L value is 3, how? The same way, 0, 1, 2, and put n is equal to 4, 4 minus 1, what will you get? 3. Sir, why we are putting n is equal to 4? Because you are dealing with n is equal to 4, that is fourth shell. So you put 4 minus 1, the last value of L will come out 3, 0, 1, 2. Okay, so for 0 we get 4s. You see, in each case the value of address is changed, that is according to nl. So for when L is equal to 3, what orbital may represent? F, so that is 4f. And what will be the value of ml? Putting 3 in 12 plus 1 relation, ml is equal to 12 plus 1, you put the value of L as 3, what will you get? 3 into 2, that is 6, 6 plus 1, 7. You got? Hello child, you get the point? This is 7. So what do you mean by 7? In 4f orbital there are 7 rooms or 7 suborbitals in which maximum number of electron having opposite spin. How many? Plus minus half into 7, you get 14, right? And what will be the address of each? Okay guys, next we will go for fourth orbit, that is n shell. n shell, we will get the value of L like before. L when 0, actually L starts, you see, L starts, one moment, L starts from 0, then 1, then 2, then 3. You understand this? So now we will get 0 along 0, 1, 2, we get one more value 3. We get one more value 3 here. 0, 1, 2. For 0, L represents s orbital, that is 4s. Why it is 4s? You understand, the address of the subshell is NL. So N means here 4, that is when L is equal to 0, it represents 4s orbital, and in 4s orbital maximum number of electron will be 2. So you get the maximum number of electron in an orbital, that is 4s orbital 2. Similarly, we get the value of N. How? One more, I will make you see. ML is equal to, L is equal to 0, 1, 2, 3. You put the value of L 1. So actually, how can we get the value of L is equal to 1? So N value is, you put N is equal to 2. 2 minus 1, you get 1. 3 minus 1, you get 2. Like just like before, nothing new. And for 3, that is 4 minus 1. Here it is 4 minus 1. You see, 4 minus 1, what will you get? 3 minus 3, that is 4 minus 1, you get 3. Here 3 minus 1, you get 2. And here 2 minus 1, you get 1. And like 1 minus 1, you get 0. I hope that you understand how the value we will get. Okay, so this is 3. L value comes out 3. 4 minus 1, 4 is the value of N. So for a 4f orbital, now I hope that you can calculate what will be the value of ML. How? You see the relation? Just you have to write the value of L in this relation. 2 into, what will be the value of L? 3. So you put value of L 3. 2 into 3 plus 1, the result will 7. So here see, this is 7. That means 7 represents, there are 7 rooms in one orbital, 4f orbital. 7 rooms, that means 7 suborbitals present in the same orbital, that is 4f. So each orbital contain maximum 2 number of electrons, each of having plus up, minus up, opposite spin. Now you may ask, sir, what will be the address of each room? Yes, you can use this relation as ML is equal to plus minus L minus 1. So you can put here L value is 3. You can put minus 3 to plus 3 range. See what will you get? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So there are 7 suborbitals. Each orbital, the range of suborbitals is minus 3 to plus 3. Okay, actually these value represents the different directions of each suborbital. Okay, so we can find the maximum number of electrons present in 4f orbital. How? With the help of magnetic spin quantum number. Okay, plus up, minus up, like this, number of electrons can be filled 4f orbital, the 7 rooms. So plus minus half into 7, that means 14 number of electrons. So total number of electrons may present in 4th orbit is 32, which is again in accordance with the 2n square rule. If you put n value 4, so we get 32. Okay guys, so thus we can see the arrangement of electrons in each orbital. That means maximum number of electrons may present in each orbital, and total number of electrons may present in each orbit. So first orbit maximum number of electron 2, second orbit maximum number of electron 8, third orbit maximum number of electron 18, like this. Okay, and in fourth orbit maximum number of electron 32. So guys, I hope that all of you can understand, and if you like the video, so please subscribe my channel and share to all of your friends. Okay, bye bye, thank you. We will meet again in our next topic soon.